So when we're looking at homeostasis of carbon dioxide levels in the blood, there's no such thing as having too little carbon dioxide in the blood. Ideally, your body wants no carbon dioxide, but that's not possible because every single cell of yours is always respiring and producing carbon dioxide. So instead of having a zero amount, there's just a lower amount which is ideal. So there's the normal level of carbon dioxide in the blood, and some things can cause it to increase. But the big thing that we look at is the fact that exercise causes carbon dioxide levels to increase. Now, if you think about exercise, why would your exercise cause carbon dioxide levels to increase? It's because your muscles start undergoing more and more cellular respiration. And that means more carbon dioxide is produced as a byproduct because your muscles are working. Now, when carbon dioxide diffuses into the blood, it can actually form carbonic acid. So what it does when the carbon dioxide level gets too high in the blood, the pH of your blood will actually decrease, which means your pH of your blood becomes more acidic than it should be. So when your blood is traveling through your arteries, especially your carotid arteries, there's special sensory cells that are able to pick up the pH of the blood, and they're able to pick up that the pH is now too low. It has dropped below normal. They then send an impulse to the medulla oblongata, the respiratory center of your brain. Please don't just say medulla, you have to say medulla oblongata. And then the medulla will send impulses to all your respiratory muscles, so your diaphragm and your intercostal muscles. And what that does, it causes them to work a lot harder. So if your diaphragm is contracting and relaxing harder, and your intercostal muscles are contracting and relaxing harder, that naturally means that your breathing rate will be much quicker, and you'll probably be breathing a bit more deeply as well, which means at the end of the day, your carbon dioxide is going to be expelled at a faster rate, which will allow the level of carbon dioxide in the blood to return back to normal. So again, there is no such thing like in the other flowcharts where we have carbon dioxide decreases below normal. There's no such thing as having too little carbon dioxide, only having too much, which causes the pH of the blood to drop, which stimulates sensory cells in the carotid arteries, which send a message to the medulla oblongata, which sends impulses to the respiratory muscles to make them work harder. So your breathing rate and depth increases, and carbon dioxide will be expelled or exhaled at a much faster rate. Very easy.